Any ideas as to how to handle it?
I multiplied the 16 inches by pi. You have the 50.26, and then I divided it by the dollar amount.
Okay. If you did 16 inches times pi, what does that give you?
50.26.
But what part of the pizza does that give you? Yeah, that would give you the circumference. So what we're going to take is 8 inches squared, right? So area is pi times 8 squared, which is going to give us, what, 200.96 square inches pizza? You used the pi key, though, didn't you? Yeah. I'm using, and that's something, in my math lab, if it says use pi equals 3.14, if you use the pi key, it'll set you off by that little bit of a round off error. And with the bigger numbers, it'll be far enough off that it's outside of the allowances in my math lab. So we've got that area. Well, let's go over here and find the area of 212 inches. So yes, we're going to use 6 inches. So that's going to be, the area is going to be pi times 6 squared. So 3.14 times 6 squared is 113.04. And then, of course, times 2, because there's going to be 2 of them. 226.08. So it's definitely more pizza, isn't it? Now we need to find our price per square inch. Now, the reaction, usually the reflex is, since the square inch number is so much larger than the price, so you square inches divided by price. But that gives you square inches per dollar, which is fine. If you look at more square inches per dollar as being good, that works. But we want dollars per square inch. We want cheaper, right? So here I'm going to take the $8 divided by 200.96 square inches, which is 0.03, and so it's actually 0.04 is what it comes out to be, almost exactly, right? So 4 cents per square inch. Over here, we're going to take $10 divided by 226.08. That sounds right. 0.044, which is 4.4 cents per square inch. Remember, this was 3.99 cents. This is 4.4. So this is the better deal. This is actually a scam that Pizza Hut got busted in about 20 years ago. They did the buy one medium pizza at regular price, get the second one for $5. Well, anytime, what their standard pitch was, what they had told their servers is, if someone orders a large pizza, which is a 16-inch, push this deal on them. That you can get 2 12-inchers for this much. Well, it was way more expensive to get the 2 12-inches. It was literally 10% more to get the 2 12-inches. Okay, so now in our second hour here, we've got some stuff to cover. That's going to be a mouthful. So yes, you need some new, some clean paper and lots of it. We're going to start talking about volume. Now, along with volume, we're going to talk about surface area in a minute. So I'm going to leave some blank spots here that we're going to come back to. So what I'm going to kind of do is I'm going to kind of stick to half my page like that. Maybe a little bit more than half my page. I draw my pictures on this side. Volume, if you recall, we took that point, We pulled it in one direction to create a length, right? We took that length, we pulled it in a second direction to create an area, correct? Pretend that's a rectangle there. We're just looking at it from kind of a different view. If I take that area and move it in a third direction, perpendicular to the first, 2, I have now created a volume. The size of that volume is equal to the area times a distance or a height. A lot of you have seen volume defined as length times width times height. Well, length times width is area, right? So volume being defined as an area times a height is the same formula. But there's a very good reason why I put it this way. And that's because it fits more of our problems like this, not just boxes. The length times width times height only fits a box. So anyway, the second thing we'll talk about is going to be surface area, and we're going to come back and talk about that in a little bit. Let's take a box now. Now, for those of you who are spatially impaired, drawing that box might be really difficult. And the way I did it there is kind of ugly anyway. So I'm going to show you a little trick. If you struggle making boxes like that, make a rectangle. Then from one corner you go up and over. Draw a second rectangle the exact same size, just offset that much. Connect the corners. You have a box. This box is going to be 15 inches by 6 inches by 10 inches. Now our volume is defined to be the area of a base times a height. Now before I just said an area times a height, we want area of a base. Now the base is not necessarily the bottom. It can be. In this case it is, but it won't always be the bottom. In fact, in a box, any of the sides can be a base. The base is always one of the sides of that figure. A base is the side that is moved to make the object. So in a box here, I could take this bottom, I could, move that to make the object, right? Or could have taken one of the sides, I could have moved that, I could have slid that through to make the object. Or I could have took the front and I could have slid that through to make the object. Or the front would have slid through there. Yeah, you guys get the picture. Any of those, the base is the shape that the object is based off of. It's not just the bottom of it. In this case, though, any of the sides could be the base, so we are going to take the bottom. So we're going to use this as our base. What is the area of our base? You got it. 15 inches times, not 10, but 6. So that's the 90 inches squared. Very good. So then the volume is the area of that base, the 90 inches squared, times the height, which is the 10. inches. 900, yes, and square inches times inches is inches cubed, just like x squared times x is x to the third. That's our volume. So, again, you could have done length times width times height, 15 times 6 times 10, you would have got that same answer. Why don't I define it that way? Well, because our object is not always a box. What if our object looks like this? I will give you that's a right angle there. Length times width times height would not work here because there's no length or width or really a height. But area of a base times a height or times a distance works. What is the base of this?
15 by 20. Oh, no.
That is the base. That's the shape that was used to create this object. That triangle is what was originally formed, and then that was moved to make the object. It's the shape that this... The other way you can think of it is if you slice this thing anywhere parallel to that base, it'll be the same shape. Okay. So the area of my base, I'm just going to use A with a little b by it for area of the base. It's a triangle, so I'm going to find it by doing 8 feet times 15 feet divided by 2 because it is a triangle. So that's 60 square feet. So my volume is 60 square feet times the distance between bases. This is also a base over here, is 20 feet. So 60 times 20 is 1,200 cubic feet. Any questions so far? Because this shape here is a triangle. So I divide by 2. If it were a full rectangle here, then it would just be 8 by 15, but it's not, it's a triangle. You called it. I have a cylinder, 8 inches in diameter and 10 inches in height. What is the base of this?
8 times 5, or 4 times. 4 squared times 5.
The base is just a circle. In the area of the base, you are correct. It's just going to be pi times 4 squared. Which is 50.24 square inches. What's next? Find the volume. We take the area of the base, 50.24 square inches, times that distance between. Now, there's a base on top here. That circle's the same, right? So it's the distance between the bases of 10 inches. 502.4 inches cubed. You used the pi key again, didn't you? You had 50.265. Yeah.
Is there any way to change things?
No, you just have to type in 3.14 for pi when you need it. So that's why I use that volume as being the area of a base times a height. Is because no matter what shape I run into, it applies. In fact, oops, you still need that for a second?
Yeah.
I can run into some really ugly shapes, and it's still going to apply. Like we were looking at things that looked like this earlier. I'm going to cheat. Because I can. Let's say this shape here is let's give this here 8 feet. This we're going to give 16 feet. And we'll give this height 10 feet. The base is this shape right here, because that is the shape that could be used to create the object. Again, if I slice it, that's the shape I'm going to get, right? Of course, now the top is the same shape, so the top could also be considered the base if you wanted to. The base here is not just a simple shape. I have to do a compound shape to find the area of my base. So the area of my base, I've got a rectangle there, and I've got a half circle here. What is the size of my rectangle? Well, this side is 8 feet. This side here is not as obvious. What's the distance from here to here? In other words, what's the radius of that half circle? 4 feet, right? It's 8 feet all the way across here. So it's a diameter of 8, a radius of 4. So if that's 4 feet, that makes this 12 feet. So that rectangle is 8 by 12. Our half circle then is pi times, I just said the radius is 4 squared, divided by 2. Pi times 4 squared is 50.24, divided by 2 is 25.12 square feet. So the area of the base is 121.12 square feet. The volume is the area of the base times that height of 10, 1,211.2 cubic feet. I realize I use 10 for the height in almost all of these. That's just because I'm lazy and didn't want to make the calculation really hard for myself in my examples. But the height will not always be 10, just so you know. Any questions so far on volume? Again, that's why I define volume to be the area of a base times a height, because that makes it dramatically simpler when we get to these complex shapes. There are separate formulas you can use for them, but why when it's just area of a base times a height? So now I'm going to go back up and use my other half page. We're going to talk about surface area. Surface area is the area that it would take to cover the surface of an object. Now, we could break this down for a box. We could break it down into 6 rectangles, couldn't we? And we could find the area of each of those rectangles. But there's a simpler way to do it. and it'll apply to all the other shapes as well. We're going to divide the surface area up into two parts. The area of the base is, well, we already found the area of the base, right? In most shapes, if we found the volume, we found the area of the bases. Then there's something called the lateral area. The lateral area is the area of all the surfaces between the bases. So like over here, if we chose this to be the base, right? That bottom's the base. The top is also a base, right? That's why I said area of the bases. You're going to have to double the area of the base. The lateral area are the surfaces that connect them. So that's this rectangle up front, this end here, the back one, and then the other end here. There's actually 4 rectangles in a box that make up the lateral area. Lateral area, if I look at this box here, I could slice the corner here and I could unfold all those sides at once. Instead of finding separate rectangles, what I would get if I did that would look like this. Where this here's the length, that's the width, that's the length, that's the width, right? This here is just that height of the box. Well, length, and width, that's just the perimeter of the base. So lateral area is actually perimeter of the base times that same height we used for the volume. So let's look at our examples now. This first example for surface area. We already found the area of the base. Why did I write it down twice? Yeah, there's the bottom and there's the top. There's the base appears twice. The lateral area is going to require us to know the perimeter of the base. Well, we've got 15, 6, 15, and 6, right? Which is 42 inches, I believe, right? So then our lateral area is that perimeter of the base, 42 inches, times my height of 10 inches for 420 inches squared. That adds up to 600 square inches is our surface area. That's not so bad. Now again, for a box like that, you could just find all 6 rectangles and add them up. In fact, you only need to find 3 rectangles because all of them have an opposite side that's exactly the same. But down here, might not be so easy. Actually, it would. It'd just be 3 rectangles instead of 4 for the lateral area, but that's okay. First of all, the area of our base, we've already found the 60 square feet. Once again, I'm writing it down twice because there's a triangle over here that's identical to our base. It's the same as our base. For our lateral area, we need the perimeter of the base. Well, we've got 8 and 15. We need to know this side, don't we? How are we going to find that side?
8 squared, 15 squared.
8 squared plus 15 squared equals x squared, right? X ends up being 17 feet. So that goes in there. We get, what, 40 feet? Is the perimeter of our base. So that means our lateral area is the perimeter of the base, the 40 feet, times the height of 20 feet. 800 square feet, which adds up to be 920. For our surface area. What do you think? Happy stuff?
For now.
For now?
Because it's going to get worse.
You have little faith.
I think they're the only one who doesn't get it.
Well, does the volume make sense to you?
No.
No? Okay. What volume is, does the area make sense to you? I guess I should start there.
Not really.
Okay.
I'll figure it out.
Okay, well, I'll make sure I get the videos posted for you so you can go back through them. But the biggest thing is, remember, area is just a length times a width. And for now, if all you can get is the rectangle, that's a start. So you got 12 inches by 7 inches or whatever. That area is just length times width. From there, a volume, you're just adding a third dimension to it. So the volume, let's see, you still got the 12 inches by 7 inches. You add that third dimension, maybe that's 8 inches. The volume can just be 12 times 7 times 8 now to give you the volume. So if those are the only two pieces, if you can only get the area of the rectangle and the volume of a box, that's a start. And that'll get you through probably half the problems just with those. Okay. Let's look at our cylinder. We have the area of our base of 50.24. This is square inches. And there is a second base on top that's identical to it. Lateral area, we need to know the perimeter of the base. Well, the base here is a circle. So the perimeter of the base is found by finding the circumference of this circle as a diameter of 8 times pi, which you are correct is going to be 25.12, and that's measured in inches. So the lateral area is that perimeter of the base, 25.12 inches, times the height here of 10 inches, 251.2 inches squared. If we add those all up, it is going to be 351.68 inches squared. So you can see, once you've found the volume, a lot of the work for finding the surface area is already done. Like even in this little ugly monster we did down here. Need just a second yet, Joey? You got it? Okay. Even this little ugly monster here. We've got the area of the base. So for surface area, we've got the area of the base is 121.12 square feet. And of course the top is the same. To find the lateral area, we need the perimeter of the base. Well, we've got 12 here, 8 here, and 12 here. We need this arc here, which is going to be half of the circumference of a circle. So that circumference is going to be pi times 8, because it's a diameter of 8, divided by 2. So it's 12.56 feet. So plus 12.56 here makes that 44.56 feet is our perimeter of the base. So the lateral area is that perimeter of the base, 44.56 times, I'm guessing my height was 10, and yes it is. Times 10 is 445.6. That's square feet. So that gets all added up. $687.84 square feet is my total surface area for that. Now, in the textbook, it does give formulas for the different shapes. So if you want to fall back on just matching the formula to the shape, you can. I did it differently here intentionally because I don't like memorizing formulas. So if I can get just a couple of basic concepts and I can figure out everything else from there, I'll do it. For those of you that are visually inclined, this might make more sense doing it this way rather than memorizing formulas. For those of you that struggle with the visualization, going back to the book and looking at the formulas and just, okay, when I see a box, this is my formula for volume. When I see a cylinder, this is my formula for volume. That might work better for you. I didn't put them in here because the book already has them, and all you got to do is find the right formula for the right shape and plug in the numbers. Well, before we finish up, we've got a few other shapes we want to look at. Yes, it is more volume and surface area. A pyramid. So this pyramid has a base that's 16 feet square. We're only going to deal with square pyramids because, well, you guys could never make me angry enough to give you something that wasn't square. So it's 16 feet square and 15 feet tall. For volume, just like with area, we related everything back to a rectangle. Let's try to relate the volume of our pyramid. I'll do this right. To the volume of a box. Now with a rectangle, we cut it in half and we got a triangle, right? If we cut this in half, do we get a pyramid? No, we get a wedge, but not a pyramid. So the volume of the pyramid is less than half of the volume of the box. We would actually have to cut off a little bit more, like this, to turn it into a pyramid. Now, what we cut off there was not half of what was left because we did the thick part on bottom we didn't cut off. It was the thin part on top that we cut off. So we're less than half, but we're not all the way down to a fourth. I could show you where this next number comes from, but again, it would require about 2 weeks worth of calculus to get there. So this is one of the few times when we're talking about area and volume and stuff where I'm just going to ask you to trust me to where this formula comes from. For a pyramid, the volume is the area of the base times that height divided by not 2, but 3. The way I remember this is just like this. If I have a rectangle, to find the area of a triangle, I divide by 2, right? How many dimensions is a triangle, a rectangle? Area is 2-dimensional, right? I divide by 2. A pyramid is how many dimensions? 3, so I divide by 3. Volume is a 3-dimensional thing, yes. So first I have to find the area of my base. How do I find the area of my base here? It is, exactly. Oops, sorry, I didn't mean to cut you off there. It's 16 by 16. Or 200 and... Wow, I'm dyslexic today. 256 square feet. Volume, 256 square feet times my height of 15 feet divided by 3. $256 times 15 divided by 3 is 1,280. So the big thing for a pyramid is you just have to remember for the volume, it's still area of the base times the height. You got to remember to divide it by 3. For surface area, we still have the area of the base, which is 256 square feet. Do we have to write it down twice?
No.
No, why not?
There's not another piece.
Yeah, there isn't another end to this thing. There's only one base. Exactly. There's not another square on the other side of this, on the other end of this thing. So the area of the base only comes in once. We still have to find the perimeter of the base. (16 feet plus 16 feet plus 16 feet plus 16 feet), which will be 64 feet here. However, in our other shapes, the lateral surfaces here went straight up and down, right? These do not go straight up and down. The length of this surface is not the same as the height. The height goes straight up and down. That 15 feet goes from the peak of this down to the center of the base. That's the 15 feet right there, hitting it at a right angle. This slant is going to be longer than 15 feet. In fact, that is what we call a slant. Sometimes referred to as the slant height. How would I find it? Well, what's the distance from here out going to be? 8 feet. It is half of our 16. 16 is all the way across. Half of that is 8.
15 squared plus 8 squared.
You bet. We've got a 15 squared plus 8 squared equals that S for slant squared. If we figure that out, we'll get this length here is 17 feet. So we figured out our slant is 17 feet. So now our lateral area is the perimeter of the base still, but instead of times the height, it's times the slant. And all those lateral surfaces used to form rectangles. Now they form triangles. So it's divided by 2.
Two-dimensional?
Yeah, his areas are 2-dimensional, yeah. So we have the perimeter of the base of 64 feet times that slant of 17 feet. It's going to be divided by 2. Is what, 544 square feet? Perfect. So our lateral area is 544 square feet. We add that to the 256 from our base to get a total surface area of 800 square feet. Since we're having so much fun, I'm catching those Snickers that are like, if I ever see you in a dark alley, you're done for, boy. A cone with a 10-inch base, a 10-inch circular base, a 12-inch height, to find our volume, we need to start out with the area of the base. The base is a circle, so how do we find its area?
5 times 5 squared.
Perfect. Pi times radius squared. So we have the diameter of 10, so the radius will be 5. So pi times 5 squared is 78.5 inches squared. How do we find the volume from that? 78.5 inches squared times the height of 12 inches. Just like the pyramid, though, we divide by 3 because it goes to a point. It's not a continuous object. It comes down to a point, which is 314 square inches, or cubic inches, I should say. That would be our volume. Surface area. We have the area of our base still, 78.5 square inches. We need to find our lateral area. What do we need to know to find the lateral area? Well, one of the things is the perimeter of the base. Base is still a circle. How do we find its perimeter? Circumference, yes. So pi times 10, 31.4 inches. What else do we need to know? The slant, right? Well, if I put this in here, this is going to be 12 right here, right? This across here will be 5. So I'm going to come down here and draw that out a little bit bigger. This is 12 inches and 5 inches. So this is going to be found by doing 12 squared plus 5 squared equals that slant squared. And yes, that does work out. 144 plus 25 is 169. And you square that and it is 13 inches is the slant. So now we can do the lateral area, which is the perimeter of the base, the 31.4 inches, times the slant of 13 inches. But still, it's triangle, so it's divided by 2. So 31.4 times 13 divided by 2 is 204.1. So we add that up, that is 282.6 square inches is our total surface area. So again, that's why I define things that little bit different way that I do, because I think it's a lot easier to do the other shapes if you do it that way. But again, the book does give you formulas for the volume of a cylinder, or volume of a cone, volume of a pyramid, and all that stuff. So feel free to use the formulas if you need to. One last object that we're going to look at. A sphere. The formulas for volume and surface area of a sphere can be derived fairly quickly, but once again through calculus. And, well, we don't know calculus quite yet. Don't worry, we're not going to get to calculus. But, so this is going to be the final time when it comes to the areas and volumes and stuff where I am going to ask you to just trust me on the formulas. The volume for a cylinder, for a sphere, where the only distinguishing feature of a sphere is its radius. So the volume is 4/3 times pi times the radius cubed. So if my radius here is 6 feet, my volume would be 4/3 times pi times 6 cubed. So to punch out the calculator, just do 4 divided by 3 times 3.14 times 6 caret, or to the power of 3. So 904.32. That's going to be feet cubed for volume. So that formula there needs to find a special spot in your notes where you can find it easily. The surface area of a sphere is 4 times pi times the radius squared. So for this shape, it's 4 times pi times 6 squared. Otherwise known as what, 452.16? Perfect. Square feet.
Well, that's a lot easier than the other surface areas.
Just giving the formula. And like I said, there are just formulas there for the other ones. The book does not discuss surface area of those other shapes. So my math lab doesn't discuss surface areas of those other shapes. Surface areas will not appear in the homework or on a quiz. On the test 4, there will be 4 surface areas that will each be extra credit. So if you can do the surface areas, they will appear as extra credit. If you can't do them, it won't hurt you. Well, I think in the 2 hours and 20 minutes I've been talking, I've done enough damage for one day. There is a new quiz due for tonight at 11:59 p.m. There's a new homework that won't be due till Thursday at about noon. Hey, I won't give you any new homework or quizzes tomorrow.
That's awfully nice.
That's awfully nice of
It's
you.
every day we come
Yeah.
here, we can expect to do quizzes.
Yeah.
And I looked at the quizzes and stuff, and it didn't say we had a quiz today.
It hadn't appeared yet. It didn't appear yet.
Yeah.
It'll appear.
Magically
It
appear
came up at
when I
8
leave.
o'clock. Yeah.
Yeah.
Usually they appear at 8 o'clock in the morning. Okay, that's enough for today.